The apocalypse may be a popular subject of sci-fi films, but there are some very real scientific theories in danger of becoming reality. These include being blown to smithereens as an asteroid smashes into Earth and a highly infectious pandemic that wipes out huge swathes of the global population within days. However, the most probable is the eruption of a supervolcano, according to a feature in How It Works magazine, which details 7 of the most devastating scenarios and threats facing mankind. A supervolcano blows. Supervolcanoes are the leviathans of volcanism. Defined by their ability to blast more than 240 cubic miles, 1,000 cubic kilometers, of material into the air, they are 1,000 times larger than the 1980 Mount St. Helens eruption, the most destructive volcanic eruption in recorded U.S. history. Geologists have never witnessed a supervolcanic eruption, but by looking at remnants of previous cataclysms, they can piece together alarming details. These eruptions could rain debris and fiery destruction on a geographical region as large as Europe, but it would be the gases they inject into the stratosphere that could spell disaster for humanity. During a supereruption, a scalding plume of gas would belch almost to the edge of space. Leveling off, it would spread out around the globe, forming a veil of sulfate aerosols that would persist for several years and trigger a volcanic winter. The veil would reflect and absorb incoming solar radiation, warming the upper atmosphere and preventing heat from reaching the surface. The result would be extreme instability in the climate system. Surface temperatures would tumble rapidly, leading to agricultural collapse and famine, and some even speculate these conditions could lead to the onset of an ice age. Thankfully, such catastrophic supereruptions are rare. The last we know of occurred 27,000 years ago in New Zealand. But they are inevitable, and critically, we have no idea when the next one will strike and absolutely no way to prevent it. Nuclear winter. With the power to demolish entire cities in seconds, nuclear bombs are the most devastating weapons on the planet. In many ways, the people annihilated in the first moments of a blast could be considered the lucky ones. In the 1980s, prominent scientists including Carl Sagan warned that a nuclear war between the US and the Soviet Union could drive the globe into a catastrophic nuclear winter. Incinerated cities and forests would send heaving clouds of sun-blocking ash into the stratosphere, and it could take years for particles to be rained out. In a worst-case scenario, it is predicted that 99% of the sun's light would be blocked for several months, resulting in noontime twilight and the halting of photosynthesis, meaning food could become scarce. Surface temperatures could additionally plummet tens of degrees below normal levels for years or even decades, bringing crippling Arctic conditions to the entire globe. Plants, animals, and humans would then perish in the darkness. Asteroid impact. Asteroids are hunks of rocky space debris, left over from the creation of the planets, which whiz around our solar system, orbiting the Sun. From time to time they cross paths with us, and, while impacts on the scale of the infamous 6.2-mile, 10 kilometers, dinosaur destroyer are rare, an asteroid a fifth the size could spell disaster for civilization. With energy greater than 10 million Hiroshima bombs, the impact shock would flatten everything within a 186-mile, 300 kilometers, radius. Dust and debris would cause an impact winter, and most living things would perish. Alternatively, an ocean strike would trigger monumental tsunamis, obliterate entire coastlines and inject seawater into the atmosphere, destroying huge swathes of the ozone layer and exposing survivors to devastating levels of UV radiation. Runaway greenhouse effect. The greenhouse effect is essential to life as we know it. Just like a glass greenhouse lets in light but traps heat, insulating gases in our atmosphere protect us from the deathly cold of space. But since the Industrial Revolution, humans have been blamed for upsetting the delicate balance of the atmosphere. Concentrations of carbon dioxide, released when fossil fuels are burned, as well as other greenhouse gases, have risen at an alarming rate, forming a thick blanket around Earth, trapping excess heat and nudging global temperatures upwards. While warmer weather might be welcome in some places, feedback loops complicate the effects of higher temperatures. Increased evaporation will cause denser cloud cover, exacerbating the warming effect because clouds themselves are strong insulators. Long-standing carbon sinks, rocks and oceans that pull carbon dioxide out of the atmosphere, are predicted to become unstable and release their stores, accelerating the problem still further. Scientists warn of a tipping point, a temperature beyond which the problem can no longer be dialed back. If we reach this point, a runaway greenhouse effect would cause temperatures to soar to several hundred degrees Celsius, boiling the oceans and making life on Earth impossible. The death of the sun. The sun supplies the energy for almost all of life on Earth, but all good things come to an end. When the sun's time comes and it starts to run out of fuel, its core will collapse as the outward force due to fusion can no longer balance the strong inward force of gravity. At the same time, its outer envelope will inflate, expanding the star into a red giant, and engulfing the orbits of Mercury, Venus, and potentially, Earth. Eventually, the dying sun will transform into a dense white dwarf surrounded by a dazzling planetary nebula. Humans won't be around to see this. The sun's fuel supply will start to run low about 5 billion years from now, but Earth will be inhospitable long before. Gamma ray burst. Gamma ray bursts, GRBs, are the brightest events in the universe. Produced by the explosion of massive stars, they emit focused beams of intense gamma radiation. They can last anywhere from a fraction of a second to several hours, and can release as much energy in 10 seconds as the sun will produce in its entire lifetime. If the Earth were unlucky enough to get caught in a GRB's almighty death beam, the effects would be catastrophic. It would trigger atmospheric chemistry that would destroy the ozone layer, leaving life on the surface exposed to deadly ultraviolet radiation. Global pandemic. A pandemic is an outbreak of infectious disease that spreads throughout much of the globe. Human history is punctuated by debilitating pandemics and, despite medical advances, it's only a matter of time before we see another. Today's standards of sanitation and medical research help us stay one step ahead of most infectious agents, but widespread international travel and increased population densities make it much easier for a global pandemic to threaten us all. In 2003, SARS, severe acute respiratory syndrome, a serious form of pneumonia, spread to 6 of the world's 7 continents within months, infecting an estimated 8,000 people and killing 750. More recently, Ebola, a grisly disease ravaging West Africa with a death toll over 11,000, threatened to go pandemic in late 2014 after cases seen in travelers arriving back in North America and Europe. Emerging diseases pose the biggest problem, since they involve unknown pathogens with no existing vaccinations. The most dangerous are highly contagious but have delayed symptom onset, meaning that infected people unwittingly spread the disease to many others before realizing they are sick. Shape-shifting diseases that mutate fast are almost impossible to vaccinate against. In today's hypermobile, city-dominated world, a deadly disease combining these 3 features could spell doom for the human race. As to which of these doomsday scenarios will become a world-ending reality, it is anyone's guess. Optimists would assure you that humanity will avoid foolish nuclear wars, begin to behave responsibly in response to climate change, and stay one step ahead of emerging diseases. These things, at least, are feasibly within our control. Beyond that, we are at the mercy of the laws of physics. Statistically, a supervolcano is most likely to hit first. A devastating supereruption is thought to occur about once every 100,000 years, whereas world-threatening GRBs and asteroids rear their heads perhaps only once in every 500,000. In truth, it's likely that a combination of catastrophic events, and a chaotic human response to them, will secure our demise. If they don't, the sun will be hot on our heels in a billion years' time.